here we go now. On a, so, here's a standard normal distribution curve. So how do I know it's standard? First of all, maybe they told me. If I wasn't told, look at the base. These are z-scores. So anytime you have a normally distributed curve where the horizontal scale represents z-scores, then automatically I know that this is a standard normal distribution curve. And automatically I know that the mean is 0 and the standard deviation is 1. Automatically, right? Because other scenarios, you might see situations where this is not true. But I know that this is true because of the fact that I have z-scores. And you're asked to find the area between these two particular z-scores. Find the area shown. Now, there's another way to ask for the same thing. If I randomly select one z-score, find the probability that the z-score is between negative 0.84 or 1.28. You know, this is another way of asking for the same thing. So, all right, obviously this area is not a geometric shape, so I can't just go back to geometry and find, a formula from there. So how do I do this? Well, there's two ways you could do this. One method is to use what we call, we have all these tables that actually calculated it all for you because you need calculus to do this. You guys aren't taking calculus. Or another method is to use the graphing calculator. So TI-83, TI-84, whatever. If you're looking for area under your standard normal distribution curve, you're going to need something called normal CDF. Oops. Normal CDF. So where do I find normal CDF? So here's my TI-84. 83 is the same thing. You're going to be here a lot. In above vars is distribution. We've gone there before for binomial. We're coming back here again. So second vars. Now you guys use this for binomial, but now we're doing normal CDF. Don't confuse normal PDF. Normal CDF. Oops. So let me go through that one more time. So again, above vars is distribution, and we were there for binomial, so we need to pull that up. So second vars for distribution. You were here for binomial, where we want normal. We want normal CDF, not PDF. You want CDF, you want cumulative. You want it to basically give you a total. So go to number 2, normal CDF. And then it's going to ask you lower, upper, you see it already has the mean equal to 0 and the standard deviation equal to 1. If that were not there, then I would have to put that there because I know it's a standard normal distribution curve. Lower and upper. So what is the lower bound? So those of you that have a TI-83 and you don't have, the 84 where it lists it this way, you're going to want to write it in this order. Normal CDF parentheses, lower bound, upper bound, and then, automatically without putting anything after that, it's going to do standard normal distribution curve. So you're bounding the area. This is the lower z-score, this is the upper z-score. In between these two, this is the area I want. So let's do it for this case. So let's write it out first. If I want to find this area, I already have the two z-scores that I'm bounded by. So I want normal CDF, because anytime I'm finding the area under a standard normal distribution curve, I want normal CDF. My lower bound, what's my lower bound? So the lower bound or the left bound of this area is given as a z-score, negative 0.84, so negative 0.84. And the upper bound, so comma, the upper bound given also is 1.28, 1.28. So this is going to do it for me. So let me go back to my calculator and show you guys how to do that. So let me do it again. I'm going second vars because I want to pull up distribution. This isn't old. Ignore that for now. I want normal CDF, enter. My lower bound, what was my lower bound? So my lower bound was negative 0.84. This is your negative sign, by the way. Do not use the subtraction for negative. I get students that do that every time and they get an error. Your calculator does not recognize this as negative. It recognizes it as subtraction, and it recognizes this as negative. Negative 0.84. My upper bound is 1.28. 1.28. I don't have to change the mean or the standard deviation because that's already there. Enter. You'll see that those of you, that have a TI-83, you'll have normal CDF, parentheses, this. You might not have this part, which is okay, but we'll use that later anyway. Enter is 0.699. So it did it for me. That is the area under the curve in between those z-scores. Therefore, that is the probability that I randomly select a z-score in between those values. Again, finding area is the same thing as finding probability. So 0.699, right? Approximately 0.699, or if you're doing probability, 69.9% if you're doing probability. Find the area, this is the area. So the percentage won't count here. If I'm looking for probability or percent, then I would pull that in. But so again, you're given a curve, a normally distributed curve with z-scores, so automatically it's SND. You're asked to find an area. Here's the area you're asked to find. So you're going to use normal CDF. If you don't have a graphing calculator, you have to go to tables. That's a whole other situation. Graphing calculator simplifies this stuff. And then input your values. So obviously, you're going to have different scenarios. So here's what I mean.
I'm sorry, but excuse me, Professor, but isn't it negative? Wouldn't the answer be a negative?
No.
0.699?
Do you ever get negative probabilities?
Did you put in a negative 0.84?
Uh-huh.
Or was that positive 84?
No, negative 0.8. So negative 0.84 to positive 1.28, right? So z-scores could be negative, but probability cannot. Area will never be negative. Area cannot be negative. Probability cannot be negative. Z-scores can be negative. Your output from normal CDF will never be negative because it represents an area or a probability. It will always be positive. And it will always be less than 1, between 0 and 1. This one's different, right? I don't have a lower bound, do I? That's the difference. Other than that, I'm looking for area under the curve. So, okay, it's a standard normal distribution curve because I know that I'm dealing with z-scores and it's normally distributed. So the mean is 0 and the standard deviation is 1 automatically. I want the area to the left of 0.44. But the thing is, I don't have a lower bound because technically this goes to infinity in the leftmost direction. And let's say your calculator does not do infinity. So what do? Well, again, I'm looking for area to the left of this curve. So I'm going to use normal CDF, right? But I have to figure out what the lower bound is going to be because technically it would be negative infinity. Well, if you notice on a standard normal distribution curve, as you continue past, as you continue past 3 standard deviations of the mean, this area becomes smaller and smaller and smaller. And you can imagine as you get all the way over to negative infinity, how tiny that area would be. So small that it would barely affect the overall probability. So what am I going to use? I'm going to use a large negative number to take the place of negative infinity. So whatever, you could negative 1,000,000. Put a negative 1 with a few zeros. I have 6 zeros. Use a large negative number to represent your lower bound because negative infinity would be your lower bound and you don't have negative infinity, right? Your upper bound is going to be 0.44 because that's the highest part of this green, area that you're looking to find, okay? All right, so let me go to my calculator again then. So again, normal CDF. So where did I find normal CDF? Second, vars, normal CDF. My lower bound is now a negative large number. I forgot what my upper bound was. My upper bound was 0.44. You don't have to change the mean and the standard deviation. It's still 0 and 1. Paste is what it looks like, and then enter again. Approximately 0.670. 0.670 is my area. In this case, to the left of that z-score. So approximately 0.670. Now this is the area. If I'm doing probability, that's a whole nother situation. We'll talk about that in a second. Right now, I'm given a beautiful curve. So, not a big deal. Picture's drawn for me. Everything is beautiful. Lucky me. Let's say I'm not given the pretty picture. Let's say I'm given something like this. Standard normal distribution. So, all right, let's assume that I don't know that I'm on a standard normal distribution curve. I am not told that. I'm told this. Assume that a randomly selected subject is given a bone density test. Those scores are normally distributed with a mean of 0 and a standard deviation of 1. Just based on that alone, I'm normally distributed with a mean of 0 and a standard deviation of 1. Automatically, I'm on an SND curve, right? Automatically, just based on the fact that it's normally distributed with a mean of 0 and a standard deviation of 1. And automatically, I'm referring to z-scores. Automatically, the center is 0. Just based on that. Because every time I hear a mean of 0 and a standard deviation of 1, on a normally distributed scenario, it's got to be standard. And vice versa. If I know z-scores, it's got to be standard. You know, if I'm on standard, it's got to be z-scores, right? Give the probability of this randomly selected bone density score being greater than 0.18. Find the probability that I randomly select a bone density score and it is greater than 0.18. Well, where is 0.18 located? Well, here's 0. 0.18 is more than 0, right? This is a z-score. So I'm over here, you know, approximately, right? 0.18, this is a z-score because I'm on a standard normal distribution curve. And I want to be greater than that. So which area is that? To the right or to the left? Well, if I'm greater, then I'm going bigger. I'm to the right. So here is my picture. I don't have the picture given to me, but that's okay. I could draw it, not a big deal. I'm given the fact that I want probability, which means that I want this area that I just shaded, which means that I'm going to do normal CDF and bound it. My lower bound, what's the lowest part of this, yellow area? 0.18. What's the highest? Well, this goes to positive infinity, but let's say I can't represent positive infinity, so just make a big positive number, right? And let's approximate. Where'd you go? So let me pull up my calculator real fast. Okay, so again, normal CDF, second bars, normal CDF. My lower bound was, I forgot, 0.18, 0.18. My upper bound is a large positive number. My mean is 0, my standard deviation is 1 automatically. I know that. And enter again, 0.429. 0.429. So approximately 0.429. Now this time I'm representing probability. So this is also in percentage form, 42.9%. So, there's a 42.9% chance that I select a bone density, a test, that is greater than 0.18. So, again, right, I could be given directly the two z-scores. Find the area between these two. I could be given the pretty picture. Find this pretty area. Or I could be given a situation where I'm asked to find a probability, but I know I'm on a standard normal distribution curve because of what I'm told. And when I know that I'm looking for probability, that means I'm looking for area. So I do the same thing in normal CDF.